See if how about now?
Can you guys hear me now?
Sounds
Aha.
good.
And then there was sound. Hey, look at all these
Okay.
names I know. Hi.
There we go.
You guys all missed my wonderful introduction here. So we will give it a try again. So hello again, and thank you for joining us for our second virtual presentation of our talk series, Science Under the Dome. My name is Jessica Libby Roberts, and I am a graduate student in CU's Astrophysics Department and one of the co-organizers of the series. For those of you who haven't seen one of our talks before, Science Under the Dome was originally held every month under CU's Fisk Planetarium Dome. Unfortunately, because of the pandemic, we've had to move our talk series to online. But even though we've lost the dome aspect of our series, we still hope to continue to bring you exciting talks, and we'll continue to use interesting features of our planetarium, even though they will be virtual. So the benefit is now you actually get to watch our talks in your PJs. So our speakers in this series are normally graduate students at CU who are invited to present on anything they are interested in. The challenge is that they aren't allowed to present on their actual research. So if you are interested in learning more about our series, or are a CU undergraduate or graduate student interested in joining our series, please contact us at scienceunderthedome@colorado.edu. So tonight's talk is Busting Myths About Outer Space by Chris Gilly. Gilly is a graduate student in the Astrophysics Department at CU, where he studies the sun and solar wind. In his spare time, he is an accomplished musician who sings and plays more than 7 instruments and has even provided the music for at least one other planetarium talk. Also, parts of this talk will feature visuals from the planetarium, which will be controlled live by our navigator, Jeremy, who is also a CU grad. The neat thing about this talk is that nothing has actually been pre-recorded, so you will be seeing everything live.
If you're watching it live.
If you're watching it now. Also, if you have any questions as this talk progresses, please feel free to type them in the chat box, and Gilly will make sure to answer them at the end. So with that, I invite you to sit back and join us as we bust some myths. Gilly?
Thanks so much, Jessica. I'm really excited to be doing this. So yeah, before we get started, I just want to give you guys a little bit more of an introduction to who I am. I recognize a lot of names already watching this, so thank you for coming. My name's Gilly, and I went to Georgia Tech for physics. I got my bachelor's in 2015, and then I came here to CU, where I got my master's degree in astronomy in 2018. And now I am just studying So here I am. I've been at Fisk for about 4 years, it looks like. And let's see. So yeah, I've been working on the facilitation team for this talk series, but also I've been a TA and done some other things in the dome as well.
Additionally, it looks like we don't have any audio again. Are we good?
Can you hear me now?
Okay, it looks like we're good now.
Woo! All right. So I'm glad that this is very technical. Okay, my name's Gilly. I went to Georgia Tech for physics. I went to CU for astrophysics for my master's degree, and now I'm getting my PhD at CU as well. I've been at Fisk Planetarium for about 4 years, both in this facilitation role, running this talk series actually, but also as a TA and just doing a lot of other volunteer work. I've been in theater my whole life, at least through undergrad, where I've done 27 plays and musicals, including at my high school as well and my local community theater. So I've been in theater for a long time, so I'm going to be as animate as I can possibly be now. We don't know what he's researching. The sun, and you'll find out more. So I just want to give you a little outline of what I'm going to talk about today, because it gets a little bit philosophically deep. So we're going to just start off on some basic idea. What is truth? And surely we'll get through that without much difficulty. But I do want to mention that this is a complex subject, and there's certainly other ways of looking at the world. So this is my disclaimer saying a lot of this I researched and has been said for over the past several millennia. It's been discovered, but some things, it is going to be my opinion, and I don't express the opinion of this planetarium. So then I'm going to go into ancient astronomies and go back in time and sort of figure out how did society think of truth over the years, and how has that evolved to now when we still have a lot of modern myths in our society. And then, like Jessica said, we're going to end with a question and answer session. So think about your questions, and you're welcome to. I'm actually watching this chat in real time, so you're welcome to say things to me as we go. So this is an image some of you may have seen before. It's a painting from this French guy, surrealist Rene Magritte, which I don't know if that's actually how you pronounce it, but what I want you to do here is just think to yourself, and if you've got anyone else around you, maybe talk to your neighbor, and I want you to answer the question, what makes something true? So just turn to your neighbor and discuss that for 60 seconds, and maybe type it into the chat. Yes, the video will be available. And they're starting to come in. Yeah, let's take a look. So we've got a couple different answers here already. Truth is based on empirical evidence. That's probably a pretty good idea. Science cannot determine what's truth, rather what's false. Okay, yeah. Agreement. I guess they're disagreeing with that. What is true? Yeah. So okay, there are many different ways to define truth, right? But like, how can that be? Isn't there like some sort of real true truth, right? Is there like some actual reality that defines what the truth is? And it turns out at least one of the reasons why there's these definitions for what truth can be is because we don't just live in one world. We actually live in a couple different worlds, actually three that sort of overlap. So there's the world one, external reality. This is sort of what you think of when you look out at the world. It's the real world in a way, but what does that mean? Then there's also the mind of the observer. So that's totally a different space. Yes, your brain is in the real world, but like I can imagine things that are totally different, right? And then a third world is the world of descriptions and theories. So for instance, maybe math. Like math, it exists in my mind, it exists in the real world to some degree, but it's also a system that we've constructed that's acting to be a descriptive object. So then the relationship between each of these three worlds holds the key to at least three major different kinds of truth that exist in the world. So I'm just going to step through those for us tonight. So the first one is in the relationship between your mind and the world. And so that is called personal truth. And this is the truth of personal recollection and memory. It's your impression, it's your opinion. If you've ever heard that sort of idea, like you manifest the world around you, you construct your own version of it based on your beliefs. Different people have very different perspectives, and that defines their identity. And as you're going throughout your life, you might learn some things that you think are true. Like, for instance, you might learn that pickles are gross. You might learn that it's important to wear good socks in the winter, or maybe Canada's too far away to walk to. These are kinds of truths that can be true for you, but they're not necessarily universal truths, right? They're the truth of your understanding of the world we live in. Let me give you another story. So let's say that you like the violin, and you think it sounds good. So you go to a concert that's a violin concert, and you listen to it, and you're like, gosh, that's just beautiful. excellent music. Um, but there's a child in attendance as well, and this kid is just not having it. It's awful. He hates the music, doesn't want to be there, right? And maybe there's a third person who is actually a music teacher and they know all the things about the different styles of the violin. Um, and so each of these people walks out of that concert with a very different impression of what occurred. And the point that I want to hammer home here is that things that people believe are true subjectively, they're still true for that person. To the person who says violin music is terrible, it actually does sound bad to them. And maybe violin's not a good example because most people kind of think at least good violins sound good, but like banjo music or rock music or something, like there is a kind of music that you can think of that it sounds bad to you. Um, but that doesn't mean it sounds bad to everyone, right? So this personal truth, um, for each of these truths, I'm going to elucidate the theory of truth behind it. That's what it's called. It's a theory of truth. So the theory of truth behind personal truth is called the pragmatic theory. So the truth of a statement can be defined in terms of the utility of accepting it, right? So if you know that pickles are gross, then it's useful for you to keep that belief because you will avoid pickles. You won't eat them. And that will save you from the distress of having to experience a pickle. Same with violin music. If you hate violin music, um, you get utility out of believing that because you don't have to subject yourself to violin music anymore. So that's one. The next kind of truth I want to talk about is social truth or cultural truth, right? And this comes from the shared stories told among members of a community. And I just want to go straight to the theory of truth before I go into more detail. The theory of truth behind social truth is what makes a claim true is if it has coherence within a specified set of propositions or belief. Truth is derivative from coherence from the whole, right? So let's look into that a little bit more. Social or cultural truth really, again, is these shared stories, beliefs, and belief systems that exist within a society and define its culture. So, like ancestry and oral traditions and the culture surrounding that puts you in a world that's different than someone with different traditions. Same thing maybe with religion. When you look out in the world, you see the world differently than the way that someone of a different religion is going to see it. Of course, uh, topically, Republicans and Democrats do not see the problems in the world as the same problems. They look out and they have different opinions about the thing that's making the world bad. Um, and I just want to point out that shared stories too is an important thing. You know, the Watergate scandal was a scandal that occurred, but then since then in our culture, we've just decided that gate means scandal. And it's the name of the hotel is Watergate. Gate has nothing to do with that, but like culturally, it's true that if you say Butterfly Gate, Buddyfly Gate, then that's a scandal. It signals to you to know that we're talking about a scandal. But you know, someone from a different place in the world with a different national identity is not going to have that same association. To them, it's not true that gate as a suffix means um, scandal. Uh, and even just backing up a little bit, you know, mythological figures. Here in America, we've got lots of mythological figures that people believe in. And so the point is that people who are part of different social and cultural groups have different core beliefs about the nature of the world. And just like personal truths, these shared stories are real to the people who believe them. Um, so they're true, not true in the way we normally think of, but they're true because they make sense within a system. Um, and the last kind of truth is really the one that I suspect that most of you watching are going to agree is kind of the true, real true, most important true, or something. And I'm really trying to say here, it's not necessarily more true. It's a different kind of true. This is empirical truth, right? And you sort of know in your heart what that means is the physical truth or the ground truth or like what actually for real happened, you know? Um, and this kind of truth really you can figure out what it is from the name of its theory of truth. The correspondence theory of truth says what makes a claim or belief true is that it corresponds with the actual world. um, and like I think especially as scientists we tend to value this truth above the other ones. But it kind of fits into a different place in our society than these other truths do. So again, like I said, empirical truth is like what happened to who and where. It's maybe what a detective would try to determine. It's what scientists try to determine, though, like how does the world work? And even astronomers and just anyone who's a scientist is really trying to understand this, like what's happening in the real world, and then how do we describe it, right? Just to go back a little bit, what's happening here, and how do we describe it with our system? Um, so that hasn't always, though, looked like people in lab coats looking through some sort of instrument or putting liquid into some sort of dropper. Um, for a long time, people just looked out into the world with their eyes. And so the next thing that I want to do is sort of go through the history of empirical truth, how it's been understood to people throughout the ages. And so we're going to go back in time to what we call ancient astronomy. And it's all these different cultures throughout history trying to figure out what their place is in the world. And an interesting thing, throughout almost all of history, the sky has been a shared resource, um, and nature to some degree as well. But like everyone sees the sky, the same sky for the most part. So let's go back in time, way back in time to prehistory. And early peoples saw this world. They're in the world and they're looking around and they're like, gosh, I don't understand why these things are happening, but they're scary, they're powerful. Um, and so what they did is they personified them. They assigned the forces to human like gods, and it gives them a narrative, which in turn gives you power over your environment. So, okay, the days are getting shorter and shorter and shorter. The sun is setting more and more southward every day. That's terrible. We don't want that. If it goes all the way to the south, it'll never come back, obviously. So, uh, in so many cultures, you have these rituals on the solstice, on the winter solstice, to try and convince the sun to turn around and start coming back. And so that gives you a sense of power over this scary thing. The days are getting shorter. Storms. Oh my gosh, there's lightning. Why is that happening? Okay, well, Thor's just having a bad day or something. It gives you a sense of control, and also I just want to say people following these kinds of earth religions are likely to be more in tune with the forces of nature than maybe some modern scientists kind of are. Um, so these people are looking out into the world and seeing all these things that are affecting them, and one thing is the stuff in the sky. And I have to say, like, what happens in the sky really does affect what happens on the ground a ton. I mean, the sun goes up and down, and that makes it day versus night. Whether it's day or night is a big difference, right? Um, Full moon versus new moon. Um, if you have a full moon, you're going to have a bright night. You can go outside, you can hunt for fireflies, do whatever you want. You're probably not going to get hurt. But if it's a new moon, it's dark. You can't go out there. And so there even another one. And we're going to turn to the digital sky system just a little bit here. But so if you go out in the morning, right before sunrise, um, as the stars are rising, there's going to be like a last star you see before the sun rises, and they call this heliacal rising. And basically, the idea is because the Earth is going around um, throughout the course of the year, the stars that are on the horizon during sunrise change throughout the year. So when you look there, and now in the digital sky over there, what we're doing is we're holding the time of day constant, but we're running the days forward. So each day at just before sunrise, Sirius is rising higher and higher. And so the first day that you can see Sirius in the sky, that tells you that winter is coming. So you can use the sky as a calendar. It tells you about days, tells you about nights. So it's really, not a huge jump to think of, to trying to understand the sky as a place that gives you knowledge about the world, and trying to interpret what's going on in the sky. So of course I'm talking about astrology. Um, and just in general, if you are in a system where you believe that, especially these prehistory cultures, where you believe that there are these active intelligences running everything, the things going on in the sky are probably messages from them. And if we look over again at digital sky here, that's the zodiac going up, and then you can see once we start running time forward, the stars stay constant, but the planets move. And the word planet again actually just means wanderer. But so you look up and you see all these motions in the sky, and what does it mean? Jupiter just turned around. It's going backwards right now. Like what? Um, and so there's been systems throughout all these different cultures trying to interpret what's going on in the sky and use that to relate to what's going down on the what's going on the Earth. And I'll get back to astrology in a little bit. So another thing that they'd see in the sky that would terrify them are eclipses. And if you haven't seen an eclipse, I absolutely recommend you go try and see one. I saw the one just a few years ago, and I just want to kind of describe it to you because it's scary. It certainly is, especially if you don't know what's going on. Um, so, like, as the sun gets towards totality more and more, the sky begins to get darker, but also like wind begins to blow because it's colder in the shadow of the sun. Um, you notice that it's getting colder and windy. Shadows in your environment start to get sharper and sharper edged, so everything looks really eerie. Instead of these nice diffuse shadows you get from the sun, you get this really angular, rigid kind of light. Animals act as if night is falling. So when I saw it in Wyoming, uh, there were these cows in a field and they were all playing in the water, and then the eclipse started to fall and they're like, oh well, it's nighttime, so they all walked over to the middle of the field and they laid down and they just went to bed. uh, and then when the eclipse was over and the light started rising, they just got back up again and went straight back over to the water and started playing again. So it's a really interesting experience being um, in one of these eclipses. And then of course once totality occurs, you start to see the whole corona and everything around it. And so a lot of cultures used to believe that the sun was being eaten. You may have heard the Chinese think that it's a dragon taking a bite out of the sun. And you can kind of see how, like, okay, it's going to take a chunk out of it over there. Um, but even to this day, the Chinese will go out and beat on pots and pans during an eclipse to try and ward off um, the dragon. And this is one of these cultural beliefs about what's going on. Um, so you might think, well, but how often can eclipses even happen? Is this like a big deal? Do you know that 2 to 4 solar eclipses happen every single year? It's true. And they chase just a thin line across the planet. So you only, the same location will see a solar eclipse approximately once every 400 years, because just this one little line gets it. But lunar eclipses, the moon can be seen by half the Earth. So there's still 2 to 4 of them a year, but anyone on a whole hemisphere can see a lunar eclipse. And I just want to tell you about one time when it made a big difference. So there's this thing called the Battle of the Eclipse in 585 BCE. And they figured out that date actually by running the models backwards to try and see when there was an eclipse in this approximate time zone. So they figured out the year from that. But the point is, it was a battle in which the two sides had a different culture. One side had people who studied astronomy and astrology, and they knew the eclipse was coming, and they warned their soldiers not to be afraid. But the other side didn't have that, and so when their soldiers saw the sun is going away, being eaten by a dragon, they panicked and were, of course, horribly slaughtered. So this is one case for sure where knowledge of what's going on in the heavens could have saved a lot of lives for these people. Okay, so let's go forward a couple hundred years. Now we're around the 300s before the Common Era. Um, and the Greeks, I mean, they did a lot of cool stuff. One of the things that they did was they invented logic, the idea of logic, I guess. Formal term logic is the full word. And they wrote down a lot of these ideas. But what they kind of said, and Aristotle was a big one here, he said, like, okay, if it makes sense with logic, it's probably true, right? It couldn't be true if it didn't make logical sense. Okay, so then a couple hundred years after that, the Library of Alexandria burned, and it burned several times. But the point is that these ancient texts with the knowledge from the ancients became rare, and their contents stopped being a living scientific work that's updated at the university that is the Library of Alexandria. And instead, it became like, oh, this is ancient knowledge. This is Euclid. What did Euclid say? Um, and so, that's kind of fitting into this coherence theory of truth model, right? Like it's true because the ancients said it was true. But an interesting side effect of this, still sticking on the astrology idea, um, astrology, the stars don't stay the same over thousands of years. The Earth is wobbling like a top, and so this changes what people will see. So it turns out that if you know your astrological sign right now, whatever you think that you might be, I'm a Gemini. My birthday's June 17th. It turns out I'm actually not a Gemini. I am apparently a Taurus, right? Because on the day where I was born, the sun was in the constellation Taurus. It wasn't in Gemini. And even though in the ancient texts it said that it should be, those haven't been updated over the years. So um, again, this really shows that these people didn't necessarily have the current belief that we have of like we have to check against the real world. Um, so I would say this is the first myth busted here. Not all of astrology, but at least you're not the sign you think you are. Um, but let's move forward. Okay, so over 1,000 years after the Library of Alexandria was burned 5 times, Galileo comes up with this crazy idea. Um, Maybe you have to check the world to see if the things that you're saying are true instead of just believing them because they make sense. And this is really like the birth of science. And it's only 400 years ago. Like science didn't exist for the first 12,000 or so years of human civilization. And we have it now. And I just want to point out that these images are from the Galileo Museum in Florence, and I've been there, and you should go there. They have so many like thermometers and telescopes and just weird instruments. It's just fabulous. Go to Florence, Italy, in a few years. Um, so, okay, science, what is it, right? Science is a method of checking the world to see how it is. Fundamentally, that's what it is. It's not the knowledge of how the world works. That's not what science is. Science is a process by which we grow the body of knowledge, right? And what it has over some of these other truth systems is that in this case, it's repeatable. You can explain it. You can have support for a phenomenon through multiple different perspectives. It makes sense with gravity. It makes sense with electromagnetism. It makes sense with statistical mechanics. Okay, we can look at this from 3 different views, and that all kind of like fit together. Science can be done by anyone. You do need training, but it can be done by anyone, anywhere. Um, and that's the sort of repeatable thing is if you do the same experiment, allegedly, you should get the same answers. Um, and the point though is that the knowledge changes over time, right? Science says this is just not real. Like science doesn't says this, right? And when you say like science used to say this and now it doesn't, and so it's wrong now. Science isn't. You can't say that. So just to go forward just a little bit here, um, where does science fit in our triangle? Of course, it sits right here in our empirical truth zone between the external reality and our descriptive systems. So what does science do? It attempts to decrease the difference between world 3 and world 1. If science achieved its perfect goal and just solved everything, world 1 and world 2 would basically be identical to some degree. Of course, they're different in form. But that's the goal of science. And so now I want to give you a cautionary tale about science because, science gets used in ways that it's really not intended to be used. So there's this thing called scientism. And it basically just means science applied in excess. But so many people nowadays really show features of this belief system. So scientism is what happens when you put science into this social truth area of the triangle. And it started off at the very beginning as science was born in the 1600s. Like here we are already trying to destroy everything else with it. So Francis Bacon, he had this classification of learning which basically said poetry and history and all of these other non-science things are just nonsense and not worth studying. And Descartes, he rendered the universe as this giant machine and cogs and stuff, and it didn't leave any room for there to be value in art or any other form of human expression. And just generally, scientism elevates the use of reason and logic by denigrating other human faculties, especially creativity, memory, and imagination. And so that's not great, but why? And just to move through time a little bit more, during the French Revolution, they actually had churches and temples of reason, and they held services where they worshipped at the altar of, like the of science. And again, that's not, science doesn't really support that. Um, so some things that you might have heard or even said perhaps that are not supported by science. I believe that science is infallible. No way. Science doesn't believe that. I believe science can solve all human questions. No way. Definitely can't. I believe science repudiates faith-based belief systems. It doesn't. It doesn't try to do that. Um, and we'll get into why in a second. But first, I have to tell you about positivism, which is just the ultimate version of this belief system. Basically, positivism says that like the information that you experience through your senses and then interpret through logic and reason are the only thing that matters. Nothing else is real. It's the only source of knowledge that's valid. And then even took this further and said, you know, eventually all of the other things are going to fade away. Religion is going to be explained by science. Philosophy is going to be explained by science. Everything's just going to be a pure science. And anything that's not science is just completely a fantasy. Um, so, that's cool. And it's interesting. And I think a lot of people do kind of have this belief system, but, you know, it doesn't address this idea of personal or cultural truth. And so here, I will say that this is my soapbox, and you're free to disagree with me to some extent here. But science doesn't have a statement to make about whether someone's wrong for disliking the violin. It's true to them. They don't like it, period. You can't, and just to be clear, you can try to apply science to this issue, but you're not going to convince anyone of anything. Scientifically, violins are great. Cool story, bro. It doesn't matter. Science doesn't have a statement to make about whether people are affected by cultural beliefs. Tons of people are affected by Santa Claus. He is a real being who exists in our world. This one specifically. The thing that science tries to describe is whether something exists in the external world. Which oftentimes has no bearing on whether it exists to a group of people. People act as if their beliefs are true. They don't just walk around thinking, I don't believe myself or something, right? They act as if there's no cognitive dissonance, right? And their viewpoint that they have colors their whole experience of the way that they see the world. And my statement, you can disagree with it if you want, but I think it's okay for people to have cultural and personal and social beliefs. And it's not necessarily in conflict with science as long as you're not trying to talk about the same things. Does it matter to the legend of the Loch Ness Monster whether or not it's really in there? For hundreds of years, people have believed in the Loch Ness Monster, and it's affected them. Again, it's not that science couldn't try to talk to these things. It's really like it's pointless, and you're not going to get anywhere. Okay, isn't this talk actually supposed to be about myth busting? We haven't done a lot of myth busting yet. But I think it was important to give us a context of like what can science speak to, and maybe like what is science, it's not that it can't speak to it, but you're just not going to get anywhere with it. So I do want to now go into a myth. But like the world exists and scientists learn things about the world and then they describe them into our knowledge, right? And then popular science of some kind describes it to you. Okay, and maybe this is Star Wars or Star Trek or The Expanse, which is excellent. You should watch it. Or, there's hundreds of space movies out there. And when you watch them, you get this impression of what space is like, which is probably a myth in a lot of ways. And so it's sort of my goal today to cut through the popular science thing and maybe address some of the myths that you might have in your head about space. So the myth that I'm going to focus on today is space empty? Is it really empty? And like, first of all, not even all cultures believe that or even have that as sort of a social belief in their culture. Many indigenous peoples have a strong relationship with the sky. It's filled with figures. Stories about the constellations are woven through their culture. They're woven through their creation myths. And just in general, they have a deep relationship with their environment. And unfortunately, nowadays we don't really have that so much anymore. NPR says that 99% of Europeans and Americans are impacted by light pollution. And when you look at a map like this, it's not hard to believe. This thing on the left is called the Bortle scale, and it's just sort of a description of how bad is the light pollution. And these colors on the left do match with the colors on the right. So unless you get outside of a green area, at least, you're really not going to see very much. And I'm just going to zoom in onto where I live. This is Denver, and you think, okay, we've got the mountains, but like you can see the entire metro area from Fort Collins down to Pueblo. I mean, you're not going to see very many stars. You have to go out past Glenwood Springs or somewhere. You have to like climb the tallest mountain really to get out into these deep, dark skies. And so, unfortunately, that has really helped lead to this idea that I think that at least Americans might have, probably Europeans too, of this, right? Like when you think of our solar system, it's probably something like this. It's like planets. Maybe you've got the asteroid belt. A lot of people probably don't have the Kuiper belt, or like Eris or Ceres or Makemake or Vesta or all these other little ones. But like in general, you think of big rocks in the void with nothing else sort of around it. And so I want to continue this sort of story narrative, right? Okay, so in 1859, we got the first evidence that there was stuff out in space, traveling especially between the sun and the Earth. So this guy Carrington looked at the sun through a telescope, which I do not recommend. And he saw a solar flare, which most likely led to some coronal mass ejection, like what we're seeing here. And that flew through space over to us, and it caused auroras to occur on the entire planet, like all the way down to the equator. It was nuts. And the Earth was not too happy about it, even in 1850s, because they had telegraph lines. And so basically this plasma moving past the Earth acted like a big bar magnet. You rub that past some wires and it pushes electricity into the wires, and things lit on fire. Literally a telegraph station lit on fire. So it's no good. 100 years later, almost to the year, 99 years later, Eugene Parker predicted that because the sun is so hot, it's got to be just expanding off its atmosphere at all times. And he named that the solar wind. And it actually took a really short amount of time for that to be confirmed. 4 years later, we launched our first mission that left the orbit of Earth, the Mariner mission to Venus. And it had sensors to detect in space what was going on there, and it detected this wind. And now, of course, we have much better technology than we had in the 60s. And so this is an image taken from the ground by Miloslav Druckmuller. And this image is the moon in front of the sun during an eclipse. And you can see all of this magnetic structure around it. And solar wind is always moving out along these lines. And here it's slow here and fast here. As we look out deeper or a wider field of view, you can see this stuff kind of maybe almost out to the edge of the screen here. And so we've got a lot of instruments. This one is LASCO, and it basically blocks out the sun and then looks at what's coming off of it. And this is from 1996, actually. So we've known this for a while. We've had these kind of videos of stuff coming off of the sun. And you can see it on the right here is the surface of the sun. On the left here is the Earth, and it's a logarithmic scale. So this is all really quite close to the sun, and then it gets the Earth is over here. And the point is that we can see blobs of plasma leave the sun, fly through space, and we can even detect it when it hits stuff near the Earth. We actually have a ton of spacecraft in space now, and these are just the ones that measure the sun and the Earth. One of them in particular I really like is called ACE. And it acts sort of like a buoy. It sits at the gravitational equilibrium between the sun and the Earth, so they're kind of pulling on it equally, and it's able to sit in this stable orbit, the Lagrange L1 point. So it's just anything that's gonna hit the Earth is gonna hit this satellite first. And we can see magnetic field, the angle of the magnetic field. You can see density, solar wind speed, and temperature. And the point here is that it's never zero or undefined or anything like that. The density, it fluctuates. It might even get lower, but it's always there. There's nowhere in space where you can go where there's just nothing there. And yeah, looking at the density. And I just want to say, like, even if you go out into the deepest reaches of the galaxy or somewhere, like in any given little cube of space, there's going to be light traveling through that cube from all directions. There's going to be magnetic fields, either from a nearby object for it to be strong or just a weak one. There's cosmic rays coming from all directions, and even just regular old density. Again, this is the sun's surface is here on the left, and the Earth is over here on the right, and the density drops fast, but there's no floor, there's no 0 point. It just gets less dense and less dense. Um, and so as we zoom back out again, I just want to show that, like, when I think of space, I'm not thinking of, empty space at all. I think of giant magnetic fields and bubbles, and I think of solar wind impacting our field and being deflected. As we zoom out, the whole solar system actually looks quite similar to that. Um, there's the sun, and it's got this bubble around it of its solar wind blowing out. But we sent out these probes, and they were able to determine, we're in a bubble, and outside of that bubble is still stuff. There's a bow shock at the front. There's all of these different structures, termination shock, heliopause, what have you. And when we look in the space between the stars, we can actually see stars sometimes that are just, for some reason, maybe they interacted with a black hole, maybe they did something, but they are just trucking it through the galaxy, and they leave a wake behind them. This is a nice vortex sheet. This one's kind of wobbly. I love this one here on the upper right because it looks just like this boat. The in between the stars in our galaxy is an ocean of hydrogen. And it really does have dynamics. And you even get like this wave in the front of the boat. That's what this bow shock is here. So that's pretty cool. And we're at the level of the stars, right? But let's go back to our story. That, like, before 1923, they looked out with telescopes and they saw blobs like this, and they're like, that's a nebula. That's probably not all that far away. It's not this big. They had no conception of the idea of what a galaxy was, really. They called them spiral nebulas. And so in 1923, Edwin Hubble used the Hooker telescope on Mount Wilson, which is a 100-inch telescope. And what he did is he took a picture of Andromeda, and he took a couple throughout the days, and he was able to find some stars which vary. And so they get brighter and dimmer over some period. And it turns out that if you know the period that it's varying at, that tells you an absolute measure of how bright it is, within some model that we have. And so if you know how bright it is and you see how bright it looks, that can tell you how far away it was. And this guy was like, you've got to be kidding me. Like, this math says that this thing is 2.5 million light years away, 2.5 million years at the speed of light. Wow. And so this was just, I can't overstate the amount that this just changes the whole conception of what our universe is, right? Like, it's not just us in this little thing with the stars that we see in the sky. It's, we are one universe in a whole universe of other little universes, right? And so this image you're seeing over on Digital Sky to the right, that's an artist's representation of our galaxy as we fly out of it. And we can have images like this because of the Hubble Space Telescope. So it was launched in 1990. It's the size of a school bus. I don't know if you've ever seen a mock-up of it. It is absolutely huge. And so it gets us these images like this, where each of the colors is a representative color of some ultraviolet wavelength or whatever. But like, okay, is space empty? Here's a picture. Is space empty? Oh my gosh. I don't know what this is, but I think Captain Kirk is stuck in it somewhere. Here's a galaxy, right? And it's incredible when we look out at these things to think like we are so far away from them, but also like you can sort of see like the fabric of the galaxy, right? You can see where there is galaxy and where there's not, and you can kind of think of this as a little island in the middle of nothing, right? But it turns out that's wrong, right? The Hubble Space Telescope had an instrument called the Cosmic Origin Spectrograph. And what they do is they look at a galaxy, but off of the limb of the galaxy, and they look at a star behind the galaxy, and they see if any junk gets in the way between the star and the observer. And it turns out that it does. And actually, we've only known this for like 10 years or something. There is as much matter in this circumgalactic disk around the galaxy as there is in the galaxy itself. So whenever you see a galaxy, there's more to it there than you think. And you've probably seen this image, and also over here on the right in digital sky, we're zooming out. And the idea is, you look at a tiny, tiny patch of the sky with almost where you can't see any stars. And if you take a really long exposure, you start to see all these galaxies. And this on the right is one of our surveys. And now, since the Hubble was launched, we have all of these dedicated things that, like the Sloan Digital Sky Survey, is just always taking images of galaxies every night. And we're building up this huge database that you can see here on the right of the whole universe, right? All of the points in this image you're seeing on the right, each of them is a galaxy. And you can kind of see how it's got this hourglass shape, right? The dimension where there are no observations, that's the plane of our own galaxy. You can't look out through our galaxy and see galaxies behind it. So this sort of hourglass shape is totally due to the fact that we are ourselves embedded in a galaxy. But so now I just want to ask you just a simple question, right? So if we're looking at this big thing, we kind of call it the cosmic web. So now imagine the Earth, and it's just this tiny little Earth, round. And so if you take the Earth and you draw a circle around it, and you ask yourself, like, is there more outside of it or inside of the circle? Obviously, there's way more stuff outside of that circle than there is on the Earth. And in fact, the only thing in the universe that is not in space is the Earth. So this is just my kind of, joking version of like, no, space is not empty. In no way can you possibly convince me that space is empty. So, there's stuff at every scale in space. No matter where you look, there's going to be this sort of fabric. When you zoom out, and here's the key, is when you zoom out, you can't just zoom out and then still look at a cubic centimeter, right? Like if you're going to look at a galaxy, maybe look at a cubic megaparsec. I don't know. Look at something on the size of the thing you're looking at, and you'll never find emptiness. And just this tongue in cheek, there's way more stuff in space than there is on Earth. So I'm pretty comfortable saying that this myth is busted, and I don't know how many of you had this myth exactly. But that sort of brings us into this last part that I want to talk about tonight. It's when should we bust myths? And in this case, we'll find that this myth was maybe not the most important myth that we could bust. But it's interesting because we have a finite energy. We can't address every falsehood. You just can't. There's too much falsehood out there. And there's also this idea of cultural sensitivity. Like if it's, sometimes it's okay to let a myth exist. But how do we know when it's okay and when it's not? So in this last section, I just want to talk about the difference between true and useful. Something can be false, but still useful. For instance, Newton's laws. Newton, like in the 1600s, he's like, this is how the universe is. I made this really cool equation, guys. It describes gravity as a force at a distance, and it works pretty good for like everything we've seen so far. But then a couple hundred years later, Einstein's like, ooh, the fundamental conception that you have about the way that the universe works is wrong. It's not flat, it's curved, right? Also, your equation is puny and you should feel bad. But so here's the issue, right? Einstein's theory is, especially according to the correspondence theory of truth, it corresponds with the actual world better. It's more true in that way, right? But like if I am an infantryman trying to aim a cannon, this is absolutely useless to me, right? Whereas over here, Newton's thing, that's useful. I can use this to figure out where my cannonball is going to go, right? So in this case, this one is much better under the pragmatic theory of truth. It's useful to accept this is true because it allows us to enable calculations that we could never do. But it's false. It's not true that space is flat in the way that Newton thought it was. So then the other axis is false versus harmful. Okay, something can be false, and it can be harmful, but those are separate, right? You could be true and not harmful. The sky is blue. Super, super true, probably. I mean, that's probably a personal truth if you want to get technical, but it's true and not harmful. Um, what's true and harmful? Okay, your talk sucked and you should feel bad, Gilly. Try harder next time. Maybe that's true. I hope not. But even if it is true, it would be harmful, right? And in general, like we have this idea of constructive criticism. Um, what's something that's false but not harmful? Fiction, entertainment, folk tales. It's okay. It's okay to have false but not harmful beliefs. Um, but then there's really like false and harmful, right? And false and harmful is just no good. You can microwave your cell phone to charge it. It's false. Don't try it. You can drink bleach to cure COVID, maybe. False. Do not try it. Let me tell you. Man-made climate change isn't real. Oh my gosh, it is so real. It's so real. And it is harmful for people to think that it's not real, unfortunately. And I'm just not going to justify that. You have to deal with it. So this is a conspiracy chart that I found on the internet, and it sort of talks about a lot of these conspiracies that we have, especially in American culture, I think. And it goes from grounded in reality on the bottom up to detached from reality on the top. And so all of these things are conspiracies, but they're very different. So let's just zoom in a little bit. So down at the bottom in the grounded in reality side, like, okay, big tobacco lied about cancer. That happened. They did conspire. They wanted to sell you tobacco and they lied to you. It's no good. So that's the thing that actually happened. It's true. But as we go up, here's the speculation line. The Denver International Airport. Is there an Illuminati under it or is there not? I'm actually not sure why there's any evidence to support that and why it's so close to the grounded in reality. But apparently there might be Illuminati under the Denver International Airport. And again, so we have questions, but whatever, up here we have unequivocally false, but mostly harmless. Okay, so like Elvis is alive. Crop circles. Apparently, Greta Thunberg is a time traveler, is a thing that people believe, which is false, but mostly harmless, probably. But unfortunately, the whole other half of this chart is really frustrating, right? And these are things that are either at the low side, dangerous to yourself and others, or just like, I guess just dangerous to yourself and others times 10, and the problem is, especially past this line, is they involve explicitly denying things that science says and replacing them with things that the culture says. So if you think of our triangle, now the bottom side is trying to encroach over on the scientific truth side. And that's really where we get into issues. So just to hammer this home, and this is my last slide, when are myths okay? Well, when they aren't harmful, when they don't address empirical truths that we can see with science, when they aren't used in decision making, when they bring people together, cultural shared stories, that's great. People being brought together is great. When they provide entertainment, great. Those things are okay. And even when they're useful in the terms of like Newton's laws, right? Like they're useful to use. It's okay if you don't say actually Newton's laws aren't true, right? But then you've got the other side. Like when is it important to bust myths? When should we do it? And again, these are just my thoughts, but really when they are harmful, obviously, do not microwave your cell phone. When they're deliberate deception or manipulation, when people have an agenda and they're trying to achieve their goal by spreading lies, that is something that needs to be fought. When they're used in decision making, if people have a belief system and then they become a US senator or something, and then they try to use that belief system in order to make their decisions, at least in America, you're not supposed to do that necessarily, depending on the belief system. Of course, Republican versus Democrat, obviously you can. And then the one that I did today, really, when it's a misconception or a misrepresentation of an empirical truth. So today I talked to you about space being full and not empty. And I will say that maybe this is the least important kind of myth to bust. It's probably not harmful. but I really wanted to make this talk in some way be at least vaguely accessible to people from whatever perspective you might have. Um, so I just want to leave you with this thought here. We've got this triangle, right? We live in these three worlds: the world, our minds, and our descriptions, right? Um, and between them lie these three kinds of truth. Your personal truth is how you interact between yourself and the world. Your cultural or social truth is your interaction between the systems and descriptions that we have in the world. And empirical truth is in the interaction between the world and our descriptions, right? Um, but science itself, it really can only address empirical truth. And again, I'm not telling you you can't attempt to use science to address these things. I'm just telling you you're not going to convince anyone of anything. If I come to you and say, look, scientifically, we discovered that the Loch Ness monster is not in that lake. Oh yeah, well, he was probably just hiding in a cave or something, or like science can't really address these things, not because it can't, but because they don't utilize the same theory of truth, right? Empirical truth asks, does it match the world? These things are, it's less important there. Um, so, and then again, this idea of scientism, be wary of putting your faith in science as a god, right? Science is not infallible or perfect. It is just a process we use to come to knowledge, right? And if you elevate it to some higher status than that, um, it doesn't, science doesn't leave any room for the humanities, really, in a lot of ways. Um, so with that, I just want to tell you, get out there, bust some myths. Again, there's a lot of really harmful myths out there nowadays. And I would just encourage people to be resolute against that. But here's my references. And anywhere in this presentation, you saw a little number in the upper right or left. These are associated here. Check me out at my website, gilly.space. And with that, I will open the floor to questions. And I can actually see this top chat over here. So I can watch and see. Oh, look at so many people talking.
Thank you, Gilly. And again, if you have questions, please put them in the chat box. There was a question that came up early on in the talk that I figured I would ask while people think of their questions they'd like to ask you. So the question is, we have observations that say an element such as gold is formed in the interiors of a neutron star, or the collapse of a neutron star. Should we accept this with more credence than, say, the myth about the moon and being made of cheese?
Well, it sort of seems like the moon being made out of cheese. Again, this is not something that's an empirical truth, right? We've been to the moon, we've checked, we took rocks home, there was no cheese there. I think that one kind of lies in the, it's a societal thing. It's sort of in the Santa Claus camp of like, I suspect that, or like the Loch Ness monster, like I suspect that the older you get, the less likely you are to participate in that social truth. But it's a good point. What's the difference between these two? Science has figured out the answers to those things. So if you say that gold is produced in a neutron star, that's like an interesting fact that we could build a story around, I guess. But if you say that I don't know, that's a good example. They lie in different areas, but they're gold coming from a neutron star is an empirical fact. The moon is made of cheese is a societal fact, and it's not true. I don't know. That's all I have to say on that one. I see one. How did you get the image from our own galaxy? And so, yeah, as we fly out away from the Milky Way, it's a great point. It's an artist's depiction. We can try and figure out what the morphology of our galaxy is likely to be similar to by looking out into the sky. We see the whole galaxy, flattened basically. But we can say, oh, it's more dense over there and less dense over there. So it probably has this. We kind of think we have a barred spiral rather than just a regular spiral, and that's for that kind of a reason. But yeah, it's anytime for your entire life, forever. Know this. It would take millions of years for a satellite that we send to get outside of our galaxy and take a picture of it. And then it would take at least thousands or tens of thousands of years for the signal containing that image to make it back to us. So since the dawn of the space age was about 50 years ago, that we're not going to have any images of our galaxy for a good while. Let me see if anyone else.
Are there any other questions for Gilly? Maybe one that I missed. If I missed yours, could you repost it, please?
Oh, and part of that question, what observations make someone contend that gold was formed from neutron stars? So that's really a deep theory thing. You know, we've tried to make elements on Earth and you smash them together in different ways. And, you know, I could get really into the weeds with that, but it's just really hard to build anything bigger than iron. And the main way that you do it is by pelting something smaller with neutrons. And so it gains like say 200 neutrons onto it. And then some of those neutrons are like, I don't like being a neutron, and they spit out an electron and they turn into a proton. So this neutral thing turns into a positive thing and sends off an electron. If you send 200 neutrons onto an atom, like 100 of them are going to do this. And now you've got some element that has 100 more protons than what you started with. So in general, we say that these high energy events cause the higher elements, just because we're not, I think it might not just be a lack of evidence, but it's like, I don't think there's anywhere else in the universe where there's an event that can occur that is going to throw neutrons at something in such a way that it can bind like that. And neutrons, it's or like supernovas, you know, is really where a lot of these elements are formed. Is our sun leaving a plasma trail as it moves through space? So the sun does orbit the galaxy once approximately every 50 million years. I suspect that there is not a luminescent trail in the way that some of those images I showed before, just because I think that those are typically caused by hypervelocity stars, so ones that have been kicked out of their birth point in some way and thrown across the galaxy, and they're moving so fast that they leave this wake. I think that relative to the stuff in our vicinity, we don't have a particularly high velocity. But we definitely do have a tail going to this one. We definitely do, you know, this direction to the left is the direction that the sun is moving in this image. And we've got this bow shock at front, and, you know, there's this whole tail behind us as well. So we're definitely leaving an impact, but I suspect it's not luminous, just because I would probably have heard about that. Is our solar system in a nebula of any kind? Sort of yes, sort of no. All stars are vaguely formed within a nebula. You have some cloud and it gets bumped, and then all the gas contracts into stars. So all the stars in our vicinity were likely formed in the same initial cloud. But for the most part, I think that's all been either accreted onto the stars or planets or blown out via the solar wind kind of out of our vicinity. And then again, we've gone around the galaxy several times. So that's likely been shredded to some degree. There's definitely not like a giant molecular cloud surrounding us here. Einstein said the universe is curved, but if it's curved and it's essentially a sheet that bends via gravity, then how do some objects appear higher in the z directions than other? Okay, I don't fully get the question, but I have a great answer to it anyway. So you often see space displayed as an object in this sort of like flat plane, blah, blah, blah sort of thing. This is just a projection, right? It's a slice. If you look at what it really looks like in 3D, it looks like this, right? And so what's actually happening is that near to massive objects, the grid points of space are closer together. Space itself is more dense. And that has a lot of interesting things. One thing it does, it makes you stick to the object with gravity, right? But it also makes time run slower. time runs slower when space is more dense. And that's a general relativity thing. So just in general, like when you see those like these kind of like flat rubber sheet kind of things, like try and put it into this context of what you're really looking at. It's the grid points getting closer. We have a question: will the universe reverse its expansion, and will it expand and then contract and expand and then contract an infinite number of times? That certainly could be true. The Big Bang occurred and everything's sort of flying out. At one point, we thought like, okay, maybe it'll slow down and stop and then turn around and then have a big crunch. At this point, scientists do believe that the expansion is actually accelerating, which indicates that maybe rather than a big crunch, we might have something called the big rip. So everything gets farther and farther and farther away from each other until things are too far apart for electricity to hold atoms together anymore, and everything just gets ripped out, and every proton is just alone in an island by itself in the universe. That could happen. I don't know if that's going to happen, but that's the big rip is the opposite of the big crunch. But there is also a cyclical theory. It could go out and in and out and in and out and in. There could have been 25 universes before us. I don't think we really think that at this time because of the accelerating nature of the universe.
Okay, I know we are over our time. If you have more questions for Gilly that you come up with later, feel free to email them to us at scienceunderthedome@colorado.edu. Otherwise, thank you again, Gilly. And I want to remind everyone that we do have a talk coming up next month on November 19th, where Dr. Erica Schreiber will actually be talking about climate change. It's called, I have to look it up. Sorry, it is called Extreme Weather in a Changing Climate. And that will be November 19th at 7 p.m. Mountain Time. And we hope to see you there. Have a good night, everyone.
Thank you so much for coming.
Thanks, everyone.